Of course, we don't just have to use mass, we can use all types of different units. So let's take a look at a chemical equation. In this case, we're going to take silver nitrate, combine it with magnesium chloride to form some solid silver chloride. So this will be our precipitation reaction, and some magnesium nitrate. Of course, you always want to make sure that your chemical equation is balanced. In this case, it's not. We have two chlorines on the left, but only one on the right. So I'll put a 2 there. And now I have two silvers on the right, but only one on the left. So I'll put a 2 there. And then after that, everything looks pretty balanced to me. Hopefully it is. So don't forget to balance your chemical equation. So this one question asks us, you add 12.3 grams of silver nitrate into 2.50 liters of 3.50 molar magnesium chloride. How much in grams of silver chloride can you theoretically make? All right, so again, these are word problems, so that's often tricky for students. You want to try to organize your thoughts, pull the data from the question, and try to come up with some kind of game plan. Generally, you want to think about what you want at the end. So in this case, we want how much silver chloride can we form in grams, right? So at the end of the day, I should get grams of silver chloride. And then I think about what my two components of the reaction, I'm mixing silver nitrate and magnesium chloride. So I'm going to have to do these two pieces individually, right? I'm going to figure out the theoretical yield for the silver nitrate, then figure out the theoretical yield for the magnesium chloride, and whichever one is the lower one is my real theoretical yield. So we have 12.3 grams of our silver nitrate. So we can start off with that. That is not a conversion unit. Of course, I always want to get to moles of A. Since I have grams, I can just use the molar mass. So 169.87 grams per mole. Grams and grams cancel out. Now I'm at moles of A. I need to get to moles of B. In this case, I want to go to silver chloride because that's my product and that's what the question is asking. According to my stoichiometric ratios, I have 2 silver nitrates will form 2 silver chlorides. So then those will go ahead and cancel out. And then I'm left with moles of silver chloride. I want to get to grams of silver chloride. So then I'll use the molar mass of silver chloride to get there. According to Google, it's that value right there. Moles and moles cancel out. And I get 10.4 grams of silver chloride, right? So I've got enough silver nitrate to make 10.4 grams of silver chloride. Now I have to ask myself, well, how much magnesium chloride do I have, and how much silver chloride can I get from that? So on a separate line, I'm going to take a look at my magnesium chloride and think about what kind of data we have with our magnesium chloride. We have 2.50 liters of a 3.50 molar solution of our silver chloride. If we think about this 3.50, right, we have to think about what that means. It means 3.50 moles of my MgCl2 over 1 liter of my solution, right? So that's a conversion unit. So I generally don't want to start with conversion units. I want to start with the 2.50 liters because it's not a conversion unit. Again, you don't have to start there, but it does make it easier. So I have 2.5 liters of this solution. That's in liters already, and I see that my molar is in moles per liter. So then I can use my molar next. Moles of MgCl2 versus 1 liter of solution. And now I'm at my moles of magnesium chloride, my moles of A. As soon as I get to moles of A, I can then use my stoichiometric coefficients to get to moles of B. My equation tells me that for every 1 magnesium chloride, I can get 2 silver chlorides. So then the magnesium chloride cancel out, and now I'm at moles of silver chloride. After that, I want to get to grams because that's what the question is asking for. I use the molar mass of silver chloride, which according to Google is that value right there. And then I do all my calculating. I get 2,510 grams of silver chloride. which is quite a lot of silver chloride. We can tell that one of these numbers is much less than the other, and that's going to be our real theoretical yield, right? When this reaction happens, we're going to run out of silver nitrate before we run out of magnesium chloride. And so the end result is that we can make 10.4 grams of silver chloride because the silver nitrate is the limiting reagent.